Welcome back, geometry students, for our very last day of chapter 9, which is changing dimensions. So we're going to take some shapes, we're going to change the dimensions, make them longer, make them wider, make them bigger all over, and we're going to see what happens to the area and the perimeter. A few people emailed me about yesterday's video and said, hey, what happened? What's going on? I don't know if they were like, that's disgusting, or I'm worried about your health, but I slammed my finger when I was painting in the door. I don't know if I told your class that yet. So, fun fact, it's a little bruise, so great, you get to look at that. Our essential question is a little bit longer today, so bear with me. Can I determine the effect that changing dimensions has on area and perimeter? I'm going to squeeze that in. Okay, so we're going to change dimensions, we're going to change length, we're going to change the width, and we're going to see what happens to area and perimeter. So let's start with the example 1. We're only going to do 2 really big examples, and I'm going to show you some similarities between those. So for this one, we're going to start with a little rectangle, height of 3, width of 4. We are going to, guess what, change the dimensions, but here we're only going to change one dimension. So let me just change the height, and you could pick whichever one. But just for my diagram here, I'm going to pick the height. My length or width, whatever you want to call it, that is going to stay the same. But I'm going to use some colors here today. We're going to multiply. I wanted to use a 3, darn it. Okay. We're going to multiply the height by 3. We're just going to change one of the dimensions by 3. 3 multiplied by 3 is 9. Now, let's see what effect does that have on the area. I'm going to speed through this a little bit. The area is 3 times 4. I'm not going to tell you why. We're not going to go over that. Units squared. I'm going to leave off units just because I'm going to focus on the numbers right now. The area here, 4 times 9, or 9 times 4, is 36. So what happened? When I changed one of my dimensions by 3, if I multiplied it by 3, what happened to my area? The dimensions of the area multiplied by 3 when one dimension was changed by 3. So that's going to be our little takeaway number 1. If you change one dimension by, you could call it by x, or by, I'll just call it by n, then the area is changed by n. Or if it's being multiplied by n, then it's changed by n. So that happens when you change one dimension. If you only change the height, or you only change the width, or you only change one of the diagonals or something. We're going to see there's always exceptions to the rules, right? So we'll see some exceptions in a second. But for most of our shapes, that's true. Now, example 2, we're going to set up one that's very, very similar. In fact, we're going to use the exact same equation. The exact same original shape, but instead of changing one dimension, I'm going to change both of the dimensions. So I'm going to use a different color here. I'm going to change this by 3, and I'm also going to change this by 3. So I'm going to change both of them, and we're going to see what happens. I bet there is a pattern. Who would have guessed? So we're going to find the area of both of them. If I find the first area, we've already done that. That's 12 units. My area down here is 9 times 12, which is 108. So what's happening to the area here? It's no longer being multiplied by 3. Up here, we multiplied one dimension by 3, so our area was multiplied by 3. If we change both dimensions, my area is going to be multiplied by 3 times 3. Or 3 squared, technically. It is multiplied by 9 if you want to call that too. But I want you to see the relationship of multiplying by 3 and multiplying by 3 squared, or multiplying by 9. So we're going to come out with our second takeaway for today, which is if you change 2 dimensions by n, the area is changed by n squared. So if you change both of them by n, then you're going to change it by n squared. So those are kind of your big two takeaways. You might see some perimeter relationships, like I'm going to do this really quick. This isn't necessarily something you're going to be asked about today, but the perimeter up here, the perimeter is 14. Can you see that? Ugh, a little bit, I'll use different color. I want it to be kind of subtle because we're not necessarily going to talk about this, but the perimeter is 14 down here and the perimeter is 26 there. There's no relationship. If you change one of the dimensions, there's not like a fancy relationship. You would just have to do the whole problem. If you do change both dimensions, do I have these perimeters handy? Yeah, the perimeter is 14 and the perimeter is 42. Like, they are multiplied by 3. If you change both of the dimensions, then the perimeter changes by n. So that's another little fun fact, but it's not something that we're necessarily going to use. And I said, because technically we're done, or basically done. But there was one piece where I said there is always an exception to the rule. And while this isn't necessarily an exception, it's kind of an exception to what I had said before about one dimension. So let's look at that. Circles. And I'm going to draw a little regular polygon here. So circles and regular polygons. I'm going to write a lot, and you can either write exactly what I'm writing, pause the video, or you could just kind of listen to me and write what you want. But in this case, the circle has a radius, a regular polygon has an apothem, and if you change, that doesn't look like change the radius or the apothem, you are changing area by n squared. So if you change the radius or the apothem by n, oops, I should have put that in there, by n, then you're going to change the area by n squared. The reason being is if my radius was 12, your area has radius times radius, so you're technically multiplying both of the dimensions, if you will. If there's two radiuses in the area, you're multiplying both of them. Same thing with the apothem. If you change the apothem of the area formula is 1/2 perimeter times the apothem. If you change the apothem, the perimeter also has to change. And same thing with the circle, pi r squared. If you change the radius, you're going to change it twice, and so that's why you're multiplying your area by n squared. It's a little fun fact there, you got to keep that in mind. And this is my last takeaway. If you ever get stuck or you're not sure what it's asking you, draw a diagram. If you are asked what happens when you have a square and you multiply one of the sides by 5, well, draw it out. See what happens. Draw a little diagram, multiply both of the sides by 5. What happened to the area? So draw, ooh, that was hard. Draw a diagram when you get stuck.